This is Babitha, working as Assistant Professor in the Department of ECE, Institute of Aeronautical Engineering. Today I am going to discuss about the small signal equivalent circuits of all the three configurations of the transistor. So while coming to the contents, here I am going to discuss about what is the small signal model and how we can represent the small signal equivalent circuit of the common emitter configuration, and also how we can represent the small signal equivalent circuit of the common collector configuration, and how we can represent the small signal equivalent circuit of common base configuration using hybrid parameter model. So in that, first we have to know what is mean by small signal model or small signal analysis. So about the small signal model we discussed in the last session. So in the case of small signal model, we can able to analyze the amplifier circuit by using this hybrid model or small signal model. So in order to do the analysis of the transistor in the small signal analysis, here we have some procedure. In that, first of all, we have to take the basic amplifier circuit. In that, we have to replace the coupling capacitors and all the remaining capacitors should be short circuited. And then we have to replace all DC sources by short circuit. And then we have to make the points base, collector as well as emitter on the circuit diagram and locate all the points in order to get the equivalent circuit. Then after that, we have to replace the transistor by its H parameter model. So this is a procedure to represent the any basic amplifier in H parameter model. So after representing in the H parameter model, we can able to find all the amplifier parameters. Those are current gain, voltage gain, input impedance as well as output impedance. So this is the basic circuit I am considering here to analyze the transistor in hybrid model. Here this is the source resistance which is used to connect the signal or Vs to the transistor, and this is the load resistor that is used to observe the how much output voltage as well as current we are getting from the circuit. So in order to do the small signal analysis of this particular transistor, we have to replace this transistor with proper biasing circuit with its hybrid equivalent model. So this is the hybrid equivalent model of the circuit. So the remaining all the components are as it is here, the source resistance as well as the voltage source, and at the output side the load resistance is also as it is, just we are replacing the transistor with its hybrid equivalent model. So before replacing the transistor with the hybrid equivalent model, first of all we have to short the DC sources as well as capacitors which are present in the given circuit. But here in our considered circuit we don't have any capacitors, so that's why we are not taking the effect of capacitances here. So next, how we will get this small signal model from the given transistor? See, in the case of small signal model, by using the four parameters of the transistor, that is input voltage, input current, output voltage and output current, by using these four parameters we can able to find the hybrid parameters of the circuit. So after finding the hybrid parameters, we can able to draw the hybrid equivalent circuit of the given amplifier. So in this case, among the four parameters, two we are taking it as the independent parameters. Those are Vi and I0. We are taking it as the dependent parameters, and the remaining parameters we are taking here it as the independent parameters. So these two dependent parameters are the functions of independent parameters. These two are we are taking it as the two equations. So next we can write these equations as Vi equal to HI I1 plus HR V0 and I0 equal to HF I1 plus HO V0. So these two are the equations after including the H parameters. So from this we can able to find the H parameters. HI equal to VI by II when V0 equal to short circuited. We have taken here it as input impedance, and next parameter is HR, that is V1 by V0 when input is open circuited. So this is the reverse voltage gain. And the next parameter is HF, that is equal to I0 by I1 when V0 equal to short. So this is the forward current gain of the H model. And next, the last parameter is H0, that is I0 by V0 when input is open circuited. This is the output admittance of the given amplifier circuit. So these all are the 4 H parameters of the given amplifier circuit. So by using these 4 H parameters only, we have constructed this equivalent hybrid parameter circuit. So after finding the hybrid parameters and after drawing the hybrid equivalent circuit, we analyze the circuit in order to find all the parameters of the amplifier here. Those are current gain, voltage gain, input impedance as well as output impedance. So these all parameters we have calculated in terms of H parameters by using small signal analysis. So now in this case we can able to analyze the transistor also in terms of using simplified hybrid model. So till now what we have calculated in the last session, those belongs to the exact calculations. Those gives the exact values of all the amplifier parameters. But next we are moving for the approximate calculations. Why we are moving for this approximate calculations here? Why? Because in the case of exact calculations, all are we are calculating in terms of H parameters. If we take two transistors, if you compare the H parameters of the two similar transistors, we will get the H parameters are different. So H parameter values are varying from transistor to transistor, so that the amplifier parameters are also varying here. So once again changing the H parameters, parameter values means once again we have to do the analysis to find all the amplifier parameters. So this is very lengthy procedure to calculate all the parameters. So that's why we are moving for the approximate calculations for all the 3 configurations. So how we can able to get the approximate calculations here? So to get the approximate calculations, we have some generalized rule for the amplifier circuit, that is output admittance into load resistance value should be less than 0.1. If this value is less than 0.1 means we have to go with the approximate model. If this value is HOERL is greater than 0.1 means we have to go with exact model. So first of all, to move for exact model or approximate model, we have to check the condition for HOERL product value here. So these approximate model we are going to analyze for all the 3 configurations here. In that, first of all, I am considering the common emitter configuration analysis by using simplified or approximate hybrid model. So in order to do the approximate model, first of all, we have to consider the basic amplifier in the common emitter configuration. So this is the common emitter configuration basic amplifier circuit. In the common emitter configuration, input voltage is VBE and the input current is IB. And similarly, output voltage is VCE and the output current is IC. So these four parameters we will indicate across the input side as well as the output side of the amplifier here. We can observe IB dash is the input current, VBE is the input voltage, and similarly IC is the collector current or output current, and VCE is the output voltage. So this is the H parameter equivalent circuit of the common emitter amplifier, and along with these parameters, this middle part is our hybrid equivalent circuit. So to make it as the approximate model, I am considering the parameter here 1 by HOE. So this 1 by HOE value is greater than the parallel combination of RC and RL here. RC is the collector resistance and RL is the load resistance. If this value is far greater than RC and RL means it is nothing but HOE value is less. 1 by HOE is more means HOE value is less, so that we can able to neglect that HOE value here. So once we neglect that HOE value in the amplifier circuit, there is an effect in the IC current here. So now the IC current is HFE IB, and similarly the same effect will be there in the HRE VCE source. So what is that effect means here? HRE VCE value if we write after removing the HOE into consideration. So here HRE VCE equal to IC into RC parallel with RL. Okay. So again here IC is nothing but HFE into I. So we replaced IC with HFE IB here. So the total overall HRE VCE value is HRE HFE into IB into parallel combination of RC and RL resistances. Suppose the product of this HRE and HFE value is very small. If this value is very small means we can able to neglect this particular value. But when we can neglect that means if the parallel combination of both the resistance values also less, then only we can able to remove the HRE and HFE values. And our condition, this HOE into RL value should be also less than 0.1. So when we satisfy this particular condition, and along with that this HRE HFE value is less, and also this RL parallel with RC combination value also less, means we can able to neglect this HRE as well as HOE in the equivalent circuit of the common emitter amplifier. So after neglecting this HRE VC as well as 1 by HOE in the equivalent circuit, we will get the approximate or simplified common emitter model is seen. So if we compare this circuit with the previous circuit, we removed the HRE VCE source as well as 1 by HOE resistance, so that we will get the equivalent circuit in this way. So here again we need to find all the amplifier parameters by using this simplified or approximate common emitter model here. The procedure is similar to the exact model. So here if HOE into RL value is less than 0.1 means it is approximate model. If HOE into RL value is greater than 0.1 means it is exact model. So exact model means when you are using the hybrid parameters as it is, how much values we are getting, that indicates the exact model. And approximate model means once we are removing the sum of the H parameters from the given circuit, that indicates the approximate model. So now we are going to see the analysis of the approximate hybrid equivalent circuit of the common emitter amplifier. So here we need to find the four parameters: current gain, input impedance, voltage gain, as well as output impedance. So here current gain is nothing but the ratio of output current to the input current. So from the exact model of common emitter configuration, the current gain is nothing but minus IC by IB, that is output current by input current. Here why we are taking minus sign here means the collector current direction is opposite to the load current direction here. So that's why it is minus IC we are considering. So from the exact model, the value of this one is minus HFE by 1 plus HOE into RL. So in the approximate model, we have neglected the HRE as well as HOE terms. So in our equation, we have HOE here. So if you neglect this HOE term, we will get it as current gain value as minus HF. And similarly, if we find the input impedance of the common emitter amplifier. So input impedance is the ratio of input voltage to input current. So in the exact analysis, input impedance was HIE plus HRE into AI into RL. So here we have to neglect the HRE term here so that the input impedance is approximated as HIE. And similarly, the next parameter is the voltage gain. So voltage gain is nothing but the ratio of output voltage to input voltage PC by VB. So from the exact model, the voltage gain is current gain into load resistance divided by input impedance. So here input impedance value we got here it as HIE. So I have replaced RA with HIE here. And next parameter is the output impedance. So output impedance is the ratio of output voltage to output current. So from the exact model, the output impedance, or else from that we are calculating the output admittance 1 by R0 equal to HOE minus HFE into HRE by HIE plus RS. So here if you neglect the HRE value as well as HOE value, we will get the admittance as 0. So once the admittance is 0 means output resistance is infinite. But the output resistance from the circuit, if we calculate this output resistance only for the hybrid circuit. This output resistance R0 is for only hybrid circuit, but for the overall circuit, if you calculate the output resistance, that one I am taking here it as R0 dash. How we can find the R0 dash means if we are looking from the output terminals, how much resistance we are getting, that indicates the overall output impedance. So here the R0 dash is the parallel combination of the output resistance as well as the load resistance. So here the output resistance is infinity and it is parallel with the load resistance. So we will get the overall output impedance of the amplifier is equal to R. So these are the approximated amplifier parameters by using approximate or equivalent hybrid circuit in the case of common emitter configuration. We'll see one example on this. For that, I am considering the common emitter amplifier with the voltage divider biasing circuit. So this indicates the voltage divider biasing. Okay. Here the given values are RS is given 1 kilo ohm and the R1 resistance is 50 kilo ohm and R2 resistance is 2 kilo ohm and the load resistance RL is given as 2 kilo ohm and the forward current gain HFE is given as 50 and the input impedance HIE is given as 1.1 kilo ohm and the output admittance is given as 25 microampere per volt and HRE is given as reverse voltage gain is 2.5 into 10 power minus 4. So these are the given parameters. And next we need to find from this circuit current gain, input impedance, voltage gain, as well as current gain by considering the source resistance into account, and voltage gain while considering the source resistance into consideration, as well as output impedance. So before going to the solution of this particular given example, first of all we have to check whether we need to go for the exact model or approximate model. So to check that, here we have to do the HOE into RL product. So here HOE into RL dash is, HOE value is 25 into 10 power minus 6, and the RL dash value is R naught parallel with RL, that is 2K parallel with 2K. So this value is 0.025. So this is less than 0.1. So that we can go for approximate model here. Okay. So to draw the approximate model for the given circuit, I am considering the same given circuit in the problem. So for that, we are drawing the simplified hybrid model. So for this transistor, the hybrid model is this one for the transistor. For the transistor, hybrid model is this one. In the approximate model, we are neglecting the HRE term as well as HOE term. So that's why we are not mentioning the HRE as well as HOE terms in the hybrid equivalent circuit. And along with this approximate hybrid equivalent circuit, the remaining components we need to take as it is here. The source resistance as well as voltage we have taken as it is here. And the two resistances R1 and R2 biasing resistances. And at the output side, we are having the collector resistance and the load resistance. Though we are using the hybrid model or small signal model, so that's why we are not considering the effect of the capacitors here. Why? Because capacitors are shorted here. Capacitors allows the AC signal, so that we are shorted that particular capacitors here. So next, to find the current gain, the formula in the approximate model is minus HFE. Just now we have calculated. So HFE value is already given in the problem, that is 50. So the value of current gain is minus 50. And next, input impedance we have calculated here it as HIE. HIE value also given. So this HIE is from the hybrid equivalent circuit only. But to find the overall input impedance of the given circuit, you have to take all the input resistances into consideration. These all are the input resistances here. So if you take all these three resistances, you will be getting here it as HIE parallel with R1 parallel with R2 is the overall input impedance. That value is 700 ohms. And next, voltage gain, approximated voltage gain is AA into RL by RA. So we have all the values. AA is minus 50. RL is nothing but parallel combination of R0 and RA. So 2K parallel with 2K, and RA value is 1.1K, this one. If we substitute all that values, we will be getting here it as minus 45.45. So here the gain is in negative in the case of common emitter configuration. Voltage gain as well as current gain both are in negative in the case of common emitter configuration. And next, to find the output impedance, that is nothing but 1 by output admittance, that is equal to infinity. So this is for the hybrid circuit. So for the overall circuit, output impedance I am taking here it as R0 dash, that is equal to R0 parallel with RL dash. R0 value is infinity, RL dash is 2K parallel with 2K. So we will be getting here it as 1K. And next, we need to find the overall voltage gain as well as overall current gain by considering the source resistance into account. So if we write the voltage gain in terms of source resistance, we will be getting it as gain is V0 by Vs instead of V0 by Vi. So we can write it as V0 by Vb into Vb by Vs. So here V0 by Vb is nothing but the voltage gain of this common emitter amplifier. So next we need to find the Vb by Vs value. So that is from the circuit we will be getting here it as Ra dash divided by Ra dash plus source resistance. So after substituting all that values here, we will get it as minus 18.71. So if we compare this voltage with the normal voltage gain, it is increasing here. And while coming to the current gain, by considering the source resistance, it is IL by IS. Again, we can write it as IL by IC into IC by IB into IB by IS. So here we have IC by IB value from the hybrid model. We need to find IL by IC as well as IB by IS values. So for that, I am considering only the resistance part in the output circuit. That is RC parallel with RL. Okay, and similarly, I'm also considering the input resistances from the input circuit. So from the output circuit, we can write IL by IC equal to RC divided by total resistance RC plus RL, that is minus 0.5. And similarly, from the input side, we can find IC by IB. That value is nothing but forward current gain, that is 50. And similarly, from this circuit, we can able to find IB by IS value. That value is the drop. This is RB divided by RB plus R. So after substituting all these values, we will be getting here it as 0.636. Here RB is nothing but R1 parallel with R2. So that's why we are substituting R1 value as well as R2 value here, both in the denominator as well as in the numerator. So the overall current gain is the multiplication of all these current gains, that is minus 0.5 into 50 into 0.636. It is minus 15.9. So if we compare it with the normal current gain in the hybrid circuit, it is the value is increased in this case also when you are considering the source resistance into consideration. So this is about the simplified model for the common emitter configuration. And similarly, we'll do the analysis of common collector circuit using approximate hybrid model. So for that, again, I'm considering the basic common collector amplifier circuit. And in that, this one is the hybrid equivalent circuit. And these are the input parameters as well as output parameters. So in the approximate model, we have to neglect the HRE, VC as well as 1 by HOE terms. That is nothing but we have to neglect this one as well as this one to get the approximate model. So this is the approximate model after removing the HRE source as well as HOE resistance. So again, from this circuit, we need to find all the four parameters: current gain, voltage gain, input impedance as well as output impedance. So again, current gain is the ratio of output current to input current here. So from the circuit, from the approximated circuit, the output current is I0 here and the input current is IB here. So I0 by IB. And the output current is nothing but the emitter current, and the direction of this one is opposite to I0. So that's why here it is minus IE by IB. So this value is 1 plus HFE. It is nothing but 1 plus HFE into IB by IB. So these two will get cancelled. So that's why it is 1 plus HFE, current gain in the approximate model. And similarly, if you find the input impedance, so to find the input impedance, it is the ratio of input voltage to input current. So in this case, input voltage is VB, input current is IB. Okay, and similarly, the output voltage is IE. So output voltage is VCE and the output current is I. These are the input parameters. These are the output parameters. So to find the input impedance, I am applying KVL to the approximate circuit. We will be getting here it as VB minus drop across this resistance, that is IB into HIE, minus drop across this particular load resistance, that is minus I0 into RL, is equal to 0. From this we can write VB equal to IB HIE plus I0 RL. And if we divide it with IB, we will be getting here it as VB by IB. Here IB will get cancelled, so it is HIE and I0 by IB into R. So here VB by IB is nothing but our input impedance, okay, is equal to HIE plus I0 by IB is nothing but this value 1 plus HIE. So I substituted that value here into R. So I0 by IB equal to minus IE by IB, that is equal to 1 plus HIE. That one only we have substituted here. And so this is the input impedance in the case of approximate common collector configuration. And similarly, to find the voltage gain, that is the ratio of output voltage to input voltage, that is V0 by VB. So V0 is nothing but output current into load resistance. VB is nothing but base current into input impedance. So that is I0 by IB is nothing but here current gain AI into RL by RL. So if we substitute the values of current gain as well as input impedance, okay, we will get the voltage gain as this much. And here 1 plus HFE into RL value is far greater than HIE. Okay, that's why we will get this particular value as almost 1. And practically we may get this value as less than 1. And to find the output resistance, it is the ratio of output voltage to output current with source voltage is equal to 0. So to find this value, again we are applying KVL in the circuit. So we will get it as Vs minus drop across source resistance, that is IB into RS, and drop across HIE resistance, that is IB into HIE, minus output voltage is equal to 0. So from this we can write output voltage as minus IBRS minus IB into HI. So here Vs equal to 0. If Vs equal to 0 means we will get it as minus IB of RS plus HI. So IE value from the circuit we can write it as minus of 1 plus HOE into IB. So now V0 by IE, V0 equation is this one, IE equation is this one. If we take the ratio of these two, we will get it as the output resistance. So this is the output resistance for the hybrid circuit. For the total common collector amplifier, the total output resistance is the parallel combination of the R0 as well as RL load resistance. So this is the approximate model for the common collector configuration. And similarly, we have to do the analysis for the common base amplifier circuit using simplified hybrid model. So again, we need to consider the basic common base amplifier circuit to do the analysis. Okay, and source resistance as well as load resistance in order to provide the input and to see the output here. And in the approximate model, we have to neglect HRB, VCB as well as 1 by HOB. If we neglect these two, and after approximation, we will get this simplified common base configuration circuit. So from this circuit also we need to find all the 4 parameters, that is current gain, that is the ratio of output current to input current, okay, that is minus IC by IE here. From the circuit, output current is IC, input current is IE. So that's why minus IC by IE. So this value is IC is nothing but HFE IB here, and IE is nothing but 1 plus HFE into IB. So here IB will get cancelled. We will get the current gain as HFE by 1 plus HFE. So this is the current gain in the case of approximate model. And similarly, to find the input impedance, that is the ratio of input voltage to input current. So here input voltage is V, input current is I. So input voltage from the circuit we can write it as minus HIE IB, and the emitter current is minus of 1 plus HFE into IB. So substitute this both VE and IE values in the RA equation. So here again these two will get cancelled. So the input impedance in the approximate CB configuration is HIE by 1 plus HFE. And next parameter is the voltage gain, that is the ratio of output voltage to input voltage. Output voltage is V0 here, input voltage is V. So V0 is equal to I0 into RL, and similarly VE is nothing but IE into RA. So here I0 by II is nothing but the current gain, AI into RL by RA. And here we need to substitute the values of current gain as well as input impedance. So current gain value is HFE by 1 plus HFE, and the input impedance value is HIE by 1 plus HFE, and into RL value. So we will be getting here it as HFE into RL by HIE. So this is the voltage gain in the case of common base configuration. And similarly, the next parameter is the output resistance. So that is the ratio of output voltage to output current. Output voltage is V0 and the output current is IC, collector current. So when we are finding the output resistance, we have to make the source voltage as 0. So that's why Vs equal to 0. So when the source voltage is 0 means the current through the input loop is also 0. That is nothing but base current is also 0. So once the base current is 0 means collector current is also 0. Why? Because IC equal to beta into IB. So once the collector current is 0 means the output impedance is infinity. So R not equal to infinity we will get. This is for the hybrid circuit, but for the amplifier, if we find the overall output resistance, that one I am indicating here it as R naught dash, that is equal to the parallel combination of R naught. This is the hybrid equivalent circuit resistance as well as load resistance of the amplifier. So if you take the parallel combination of the two, here R naught value is infinity and the load resistance R. So infinity parallel with RL means we will get it as RL. So R naught dash is equal to RL in the case of common base configuration. So these are the approximate model for all the common base, common emitter as well as common collector configurations. So to solve the problems, we need to remember all the exact model formulas as well as all the approximate model formulas to calculate the asked parameters in the given problem. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.